Okay. So what we're covering today and finishing up of chapter 1.1 is bounded and unbounded intervals. And the main difference between bounded and unbounded is bounded is going to have two endpoints. Unbounded is going to be going off in one direction or the other. We could have two unbounded intervals. So we could have one going this way and one going that way. Now, bounded intervals. So a bounded interval, let A and B be two real numbers such that A is less than B. So it really doesn't matter what A and B are. It's just that A, whatever value it is less than B. So we could say that B, or A is 2, so B would be what? 3. Because whatever B is, it's always going to be bigger than whatever A is. And we're talking for any number. So our first type is that we say that A is less than or equal to X is less than or equal to B. So what we're saying is any number between A and B is what we're talking about. X is just those numbers between them. Now for our interval notation, it's going to show up like this here. Because when we say A is less than or equal to B, A is less than or equal to X is less than or equal to B, is that the numbers A and B are included because it's equal, and all values between them. And since it's equal, we use brackets. We use brackets to show that they're equal in interval notation. And the graph of this will look something like this here. Now, sometimes it's going to show up as circles, but we'll fill those in. We'll fill the circles in and include A and B. Now the next one is just less than. A is less than X is less than B. So they don't have the equal sign. So in our first case, they're both equal, so we fill both in. The second case, neither one of them is equal, so we leave them open. Yep, so for the second one, the circles are not filled in because we do not have equal signs. So when it's just less than or greater than, we leave the circles open. It's only when we say that they're equal that we fill them in. Okay. You're good. Now we could have the case where A is less than or equal to X is less than B. So A would be included because we have that equals. B would be not be have it because it's not equals. So A would have the bracket, B has the parenthesis because it's not equals. And so on the graph, our point at whatever A is would be filled in. Our point at B would be open because it's not equaled. In the other case, it's just the flip. So A is not equal this time, but B is. So B would be filled in, and A would be left open. But that's all we talk about here for interval notation. So it could be that they're both equal to, so we have two brackets, no brackets where we just have parentheses, or a bracket on one side or the other. Now the other type that we have is unbounded intervals. An unbounded interval is going to be, so let A be a real number. Each interval on the real number line shown below is called unbounded. So the first one we have is X is greater than or equal to A. So any number that is greater than or equal to A will be on this interval. And the way we do this is bracket A, comma, infinity. Since we said greater than or equal to means A is included, whatever value it is, comma, infinity. And the number on the right of this interval will always be the bigger number. So here, it's infinity. Infinity is always going to be whatever bigger than whatever a is. And so when we graph it, it'll look something like this here. That's a good point. Now, because we put a bracket because it's equal to whatever that number is, yes? Now, infinity is a number we actually can't quite reach, no matter how hard we try. We can never get to infinity. Now, I used this example first hour because it's kind of hard to imagine infinity. But there's a word problem they go about talking about an infinite hotel. So imagine a hotel with infinite number of rooms. It's huge. And you have someone come to check in to the infinite hotel, even though every room is already booked. So what the desk clerk decides to do is he tells the person in room 1 to move to room 2, 2 to 3, 3 to 4. Everybody move down one room. Even though it's already full, we just made space in room 1, yes? Because 1's now 2, 2 is now 3. So now you can put one person in room 1. So we just took an infinity and made it bigger, yes? So even though I had infinity, I just made it a little bit bigger. So now there's a new, bigger infinity, yes? Okay, take that same hotel. Well, we had Hotel A. They're actually across the street. The rival hotel, Infinite Hotel, has infinite number of rooms, actually burned down for some reason. Now they want to put all the people in that hotel into the first one. So this time, you tell the person in room 1 to move to room 2, person in room 2 move to room 4, person in room 3 move to 6, move to the next even number. That means all of the odd numbers now are available in the hotel, yes? Infinite number of odd numbers, so now we move those into there. So I now doubled infinity, even bigger one. So no matter what we do, long way around, I would never be able to get to actually what infinity is, yes? So we leave it as a parenthesis because no matter what we do, we can never get there. Does that make sense? There's always going to be a bigger infinity. So we use a parentheses around infinity or negative infinity. We do the same thing with negative infinity as well. So any questions on this here? Now the next case we have is if it's just greater than, it's not equal to. So we just use a parenthesis. So on a number line, it's just going to be an open circle. Now I'm going to go on and show you the other two are dealing with less than or equal to or less than. So x is less than or equal to a, so we have parentheses negative infinity comma a bracket. And x is less than a, so parentheses negative infinity comma negative a parentheses. And whenever we write interval notation with these two numbers, the bigger number is always on the right, the smaller number is always on the left. So you can do a box or you can do a circle. Most of the time when I draw an interval or do a number line, so we'll say 4, I'll do a circle, fill it in, and when I shade, so this is x is greater than or equal to 4. I'll go above and below the number line if I'm doing it by hand just to make it easy or clear. Do little loops to show what I'm shading. So it's a little bit easier to see what's actually being shaded and what's not. Okay? Yes? On the homework, it'll give you a number line, a whole bunch of numbers on it, and gives you the option of open, different options, and you'll click on the ones and then click the numbers for the virtual one. It'll give you the option of what to do, okay? Now, there's one more on this page, which I do consider unbounded. Negative infinity to infinity. That's all real numbers. Any number in the system will work. Any questions on any of these here? We good with these? All right. So these are a little bit small. I don't know why they printed so small on this page. So they're right under the last one. So right under where we just did that, it looks like about yay for some reason. Or these here. So we want to write each of these in interval notation. So -2 is less than or equal to x is less than or equal to 3. So it's on the same interval, so our two numbers would be what and what? Well, -2 and we would have a bracket and a bracket because both -2 and 3 are included. They're equal to it. So we have a bracket. So a bracket -2, comma 3 bracket. We use the brackets to say that these two are included. And that's it. Any questions on this one here? All right, let's look at the next one. X is greater than -1. So what's that saying? So our smallest number is what? -1. Because we're saying all the numbers are bigger than -1. So what's the biggest number we can have? It would be infinity. And because we have infinity, it's always going to have a parentheses. And what about the -1? It would be parentheses because it's not included. So we'd have parentheses around both of them. Okay, so any questions on this here? We good with this here so far? Yes? Okay, let's look at the next one. So what are our two? So we have a bounded interval because we have two endpoints. And what are our two endpoints? -3 and 4. So it's not quite at -4. It's hard to see on the paper. I'm going to make sure they're a little bit bigger on the next one. So it's between -3 and 4. And we would have both brackets, parentheses. What are we going to put? Might be easier just to see the board. And a parenthesis. Is it -3? It's included because we have that filled in circle. And at 4, it's open, so we have a parenthesis. And that's it for that one there. Now, is letter D, is that a bounded or unbounded interval? Unbounded because it goes in one direction, yes? So that means most likely we're going to have infinity or negative infinity. Which one will we use? Negative infinity because it goes off towards the negatives. And the biggest number we have is 3. Negative infinity would be bracket. And that's it. That's all we have to do for these here. Any questions on these here? Oh, that's why. Okay. Now we're going to talk about set builder notation. We did a little bit of this yesterday, so we're looking at a little bit more today. So set builder notation uses symbols to define a set of terms, in terms of the properties of the members of the set. So this here, the set of all real numbers x. So all of that there is really, this is, all of this here is what that means. That bracket x is saying the set of all real numbers x. Such that, that one little bar is such that x is less than b. So we talked about this a little bit yesterday, because we talked about the set of all real numbers x. We wrote this out a few times, yes? The only time we have to write something more than this is if it's not the real numbers, all real numbers. So if we're talking about integers, then we'll have to change it a little bit. But otherwise, if we're talking about all real numbers, this is all we have to do here. And these are two examples of set builder notation that we can use. Okay, so there are two examples. Didn't take any longer. So when we look at this here, so the set builder notation, the kind of the examples they gave us, the set of all real numbers x such that x is less than or equal to a or x is greater than b is what it's telling us there. So it's talking about the interval where x is less than or equal to a or x is greater than b. So we have two different graphs. So it's possible to have more than one. And this is a way for us to be able to write it. Now the other one is for all real numbers x such that x is not equal to a. I think yesterday we used the number 6 for the last one. For all real numbers, x is not equal to 6, except for 6. And we wrote it kind of like that there. That's what it's talking about. So all real numbers, everything except for the number 6 or 4 or negative 4. So it's including everything except for that number. Okay. So when we look at this here, we're going to sketch the graph of what they tell us. We're going to do that first. So here this tells me that I have the set of all real numbers x such that 2 is less than x is less than or equal to 5. So that means what? We're talking about all the numbers between what? 2 and 5, yes? Because that's what this is. So we're talking about, so we have a circle at 2, circle at 5. Is 2 filled in? No, because it's not equal to. How about 5? And then we shade in the middle, because everything in the middle is included. And that's it. That's all we have to do for this one here. Because when it's in the middle, we shade in the middle. And it's one of the ones we would call call an and inequality, because both have to be true. Any questions on letter A? We good with this here? Okay, let's look at letter B. Here, this says the set of all real numbers such that x is less than or equal to 0 or x is greater than 4. So we have two inequalities here, kind of like the example they gave us. So let's look at the first part. X is less than or equal to 0. So at 0, we would have a closed circle, and we would shade to the left or right. And that's it. So we have x is less than or equal to 0. And the other part says x is greater than 4. So at 4, we would make a circle, and we would have it open, because it's not equal to, and then we would shade to the, and that's it. Because as long as one of the statements is true, we are good. So if we said, looked at -3, is -3 greater than 4? Well, no. Is -3 less than or equal to 0? Yes, so that works. How about 5? Is 5 less than or equal to 0? Is 5 greater than 4? So it works. Number 2. Is 2 less than or equal to 0? Well, no. Is 2 greater than 4? No. None of these numbers here work for both, one or the other. And that's it. That's all we have to do for this here. Questions on this here? Are we good with this? Yes? No? Yes? We good? Sketch the graph for the set of numbers. So the set of all numbers x such that x is less than -2 or x is greater than 0. So at -2, we will have an open circle, and we would shade to the left. It's less than -2. And at 0, we would have an open circle, and we would shade to the right. And that's it. That's all we need to do for this one here. Any questions on how we filled those in? I'll fix that in a minute. Do we need to see another example of one of these? Are we good with filling these in? Yes? We good with these inequalities? Yes? We good, Josh? If that's the case, we're going to move on to the next type. Writing the set of numbers in set builder notation. So set builder notation is our bracket x. So our first one is a set of all integers greater than 5. So can I just do parentheses x bar? Well, no, because that is saying what? The set of all real numbers x. But we don't have the set of all real numbers. We have the set of all integers. So you have to do like we did the other day, that e, that element, x is an element of the integers, or x is an integer. I believe the book, the textbook, is going to put more of x is and x is an integer such that what? What is it talking about? X is greater than 5. So we would have what? X is greater than 5. And that's all we'd have, because we're talking about that variable, and it's greater than 5. Any questions on this here? So for this one here, we would just have x is greater than 5. That's it. So we good with these two here? Try refreshing. So let's look at the next one. Negative infinity, comma 1, or negative 1, comma infinity. So here, we're talking about the set of all real numbers. Because normally when we talk about inequality, or these intervals in this interval notation, it is going to be the set of all real numbers. How would I make this statement here? Negative infinity, comma negative 1. How would we write that? So x is, I would say, less than negative 1, because since our parenthesis, it's not equal to. So yes, that's right. Or what? Now we need to do the other one. It'd be very similar. It would be x is what? Greater than negative 1. Well, looking at this here, what number are we not including? Negative 1, right? This includes everything except for negative 1. So what we could do is say the set of all real numbers x such that x is not equal to negative 1. Since it included everything except for negative 1, we can write it this way also. X is not equal to negative 1. And that's it for that one. Last two we're going to do. So when we look at this first one here, we're going to have two sets. Okay. We'll have to have two sets. Because unlike the other one that we had, 1 and negative 1 are not the same number, are they? No. So there's a gap between here. But it's going to look very similar to the last one we did. So we're going to do the set of all real numbers x such that what? Here, we're saying that x is negative 1. Or what? X is and that's all we have to do for this here. Now, we can't do the same thing as we did before because there is a gap between negative 1 and 1 that we have to include. So the two statements tell us that. And while we're at it, we'll go on and look at the last one here, the set of all integers except negative 4. So we'll start off with our bracket x, and then what? Yeah. We'll have x is not equal to negative 4, but because they threw in the set of all integers, we have to define that x is an integer and not all real numbers. Now the textbook might, or the thing might say x is an integer such that x, and have you write out or have it written out is an integer, and that's fine. That's just the same thing. This element z is just a shorthand way of writing is an integer. X is an element of the integers. It is one of the integers. And that's it. Are there any questions on anything we've done so far? Anything we've done today? We good with this here? Yes. Yes. Okay. And that is it for today's lesson.